Hello, honored algebra students. Mr. Lawrence here, and we are in the third quarter now. Yes, ladies and gentlemen, I know you know that. We're in the third quarter, and we are going to learn how to, today, graph exponential functions. I can graph exponential functions. Now, you might be wondering what an exponential function is. Remember back when we did the nth term? Oops, what am I doing? Hold on a second. Here we go. Back when we did the nth term stuff, sometimes we got answers like, the nth term might have been, oh, I don't know, 3n plus 1. I don't know if you realize that. We were learning about linear equations when we did that. And sometimes we got like an n squared minus 4. And that's something called a quadratic equation. You might remember me using that term. We haven't used quadratics too much yet, but we will soon. All right, but then sometimes, let me get rid of these, sometimes we got one, like when we did the Tower of Hanoi, where we got like 3 to the power n minus 4, something like that. Well, if I have a graph like that, that's going to be exponential, okay? And let's just review really quick here what happens. Remember, I make the t-table, and you're not going to have to make these kind of tables looking for the nth term, but I just want to prove to you that it's exponential to, dust off the cobwebs. Looking for the nth term, okay? And remember, we're going to go what? Plus 2, plus 4, plus 8, plus 16, and then it was times 2, times 2, times 2, right? And when it was doubling every time or tripling every time, it was that number to the power n. Okay, now the exponential function will usually look like this: y equals 2 to the power x. Now I have to warn you, there is no slope in these. These do not have slope. Remember I made such a big deal about, 2 to the x or 2 to the power x. They're not the same thing. Okay, and let's see if we can figure out what this graph is going to look like. We're going to make a t-table, and after a little while you won't need to make the t-table probably, but let's, just to get our basic understanding, let's do that. And I'm going to move my t-table here. Oh, it's not coming. There we go. All right. And I'm going to put these numbers in for x right into this equation right here. And then I'll figure out what y is. So let's see here. 2 to the third power, well, that must be 8 because 2 times 2 times 2. To the second power, that must be 4. To the first, that must be 2. To the 0 is 1, right? To the negative first, use the reciprocal, 1/2. To the negative second, that would be 1/4. And to the negative third is going to be 1/8. So you see, as x is getting smaller, those are getting smaller. So let me plot those. Let's see here. Hold on one second. Okay, so I need a point at 3/8. So I go 1, 2, 3 in the x direction and all the way up to 8, right? And then I go 2, 4, so I go 2 and the 1, 2, 3, 4. And then I go 1, 2. And then when x is 0, y is 1. Okay. And when I get -1, I get 1/2. And 1/4, and 1/8, which gets really difficult to show. I'm just curious, how small will this go? For example, how small can y get? I mean, if you put like -100 in for x into your t-table, you have 2 to the -100th power. Okay. Well, that would be 1 over 2 to the 100th power, right? And I'm not going to do 2 to the 100th. It's a very large number. And so 1 over that means a very small number. But is it a negative? Do you see any negative signs? No, of course it's not. It's very, very close to 0, but it's not 0. It'll always be more. And so in an exponential graph, what you end up having is you have an imaginary line called an asymptote. And I'll write that down so you parents don't think I called you a bad word. It's an asymptote. Okay? Asymptote. And the way I think of an asymptote, it's a force field, a barrier. It keeps the graph from crossing it. And all exponential functions will have an asymptote. It's a number they're approaching, but will never get to or go beyond. Okay. And so my graph actually goes something like this, and it's kind of difficult to draw it on here, but I'll do the best I can. And it starts to curve. Okay. And then, oops, it shoots way up like that. Okay. It'll go to the left, almost appearing to be horizontal. It never will, because it's at 1/8 for an y coordinate, and then it'll be at 1/16, 1/32, 1/64, 1/128th, 1/156, etc. It'll get smaller and smaller and smaller, and get closer and closer and closer to that green line, but it'll never get there. No, by the way, you want to do your best to make that a curve. Like I said, it's a little bit difficult using the airliner, but I really didn't like the way that looked. I'll tell you what, I'm going to draw that part again. That's a little bit better. Okay, don't worry. As long as you do the right approximation, I'm not going to grade you on the exact curviness of your graph. But so you see, now it will not have an asymptote in the x direction or a vertical asymptote of any sort. It's only going to have a horizontal one. And what's going to happen is it's going to go steeper and steeper. Like this kind of looks like it has a slope of 1/1, and then this looks like it has a slope of 2/1, and then 4/1. The next slope will be 8/1, then 16/1, then 32/1. It'll just climb and climb and climb. It goes on forever, and this is how we depict that. Okay? All right, let's check out another one here. Now that you see the basic shape, I'm going to put y equals 1/3 to the power x. So let's put 2 up there. I get 1/3, 1/3, so I'm going to get 1/9. 1's going to give me 1/3. 0 power is going to give me 1. If I put a negative exponent, I'm going to use the reciprocal, so I'm going to get 3. And then I'm going to get 9. Well, let's see how this looks. All right, 2 is at 1/9. So, where did my points go? Hold on, let me go get my points. Points. Oh, points. You've been infinitely cloned, so I can just take one of those with me. And I will infinitely clone him. Abracadabra, you are cloned infinitely. All right, so I need a point at -2, +9, and I scroll down just a wee bit too far. All right, and I need a point at -1, 1, 2, 3, 0, 1, 1, 1/3, and then 2, 1/9. So it's really the same graph. It's going the other way though. Look, here's that asymptote, and if you're going to draw the asymptote, and I recommend it, but do it as a broken line because it's not really a part of this graph. Okay, and let me get back to my calligraphy pens, and I'll draw him, and he's going to come like this, very close to that asymptote, never touching it, curving up, and there we go, and it's goes right there. And there it is. Okay, now some of you are wondering if the asymptote always has to be at the x-axis. No, of course not. I want you to think, see if you can tell me tomorrow what might move that asymptote to a different position. I will tell you in all these graphs, the asymptote will be horizontal. Okay, we may do some later with a vertical asymptote, but definitely not in this. All right, so that's pretty much it. We made a little quick t-table, got the curve, and drew our asymptote in, and then drew our curve. So that's your lesson for today. We'll get some practice with that tomorrow. You should be able to have a pretty good effort at graphing exponential functions. And then in a day or so, we'll see how this stuff is used. All right, Mr. Lawrence signing off. Good night, everybody.